Okay, I think we're all set up to go. Let me so first off, we're going to go over 2.4 today. No, I'm sorry, 2.3. And if we've got enough time, we can get, well, no, we're not going to go to 2.4 because the class yesterday only got through with 2.3. So even if we get done a little early, I'm just going to stick with 2.3 to kind of follow along with them. If you guys haven't, does anybody have any questions about, you guys just had a test, right? So there wouldn't be any homework questions. So let's get straight to the, let's get straight to the lecture. Switch it, there we go. Okay, so section 2.3, which is on slope. So before I get rocking and rolling on slope, I'm going to go open my chat up here. And I'm going to ask you, when I say the word slope, what do you think of? Like, you can put it in the text, the chat box thing in Zoom, or you can just tell me, you can unmute yourself and tell me. That's fine. I'm going to sit here until, yeah, it's y equals mx plus b, Celeste, or CJ. But yeah, you're right. What else? When I say slope, what's something else you guys think of? I'm waiting. Rise over on perfect, Zoe. Sadness, yes, I can see that too. Who are you, Pixel 2? Brianna, okay. Rise over ride. Yeah, those are normal. Okay, so let's start first with CJ Celeste wrote, it should be y equals mx plus b. But we do use the letter m for slope. I don't know why, beats me, but we use letter m, and that's just how it is. But that's an equation for slope. That's slope-intercept form, which we're going to get to later on in the lecture. But then let's talk about the rise over run aspect. Rise over run. So really what slope does is gives a numerical output for the slant of a line. Slant's another way to think of it, okay? The slant of a line. So it's just a numerical way to show how great it is, or how small it is, or how, how negative it is. So if we look at a basic example, and I'm going to just use this rise over run concept to find slope, okay? Use a lot of different colors today. So if I had, let's say I've got some line, we'll do a few different lines here. I've got some line and it starts at -1, 1, and it goes to 1, 2, 3, 2. Okay, so we've got -1, 1, and then we've got 3, 2. And if I wanted to find the slope, the easiest way to do it is think of it in this rise over run terminology. Okay, so I'm going to draw a line for this slope. Just draw a line, I should say. And I'm going to think of it in a stair-step pattern, right? So I'm going to go from this far left point, and I'm going to get to this other point. So I need to go up 1, that's my rise, and then I run 1, 2, 3, 4 units. So it's rise 1 and then run 4. So the slope for my blue line, I got a rise 1 and a run 4, right? We have a slope of 1/4 or 0.25. It's actually really nice to leave slope in fraction form, even if you have like a whole number like 3 or 2, still writing it as 3/1, because it tells you the rise and the run, okay? But what I want to get across here, though, is this, since it's a straight line, it holds this slant the entire time, right? If we were looking at curvy lines, right, they wouldn't have slopes, right? There's not a straight line. It doesn't hold the same pattern of change throughout. And what this means is for every 4 units in the x direction we run, we're going to rise 1 unit, okay? So every 4, and this is consistent for the entire line, right? Consistent for the entire line. We could do that over and over and over again, and it's no big deal. Now, why, if you're going to go on and take like a business calc class or a calculus class, what you need to focus on slope, because what slope is talking about is really change, right? Slope doesn't tell us where the line occurs. It just tells us the change in the line, right? Or if we're talking about, a real life example, if we were looking at, time and money, that slope would tell us, hey, for every 4 months, we're gaining $1 or whatever time and money was. For every 4 days, we're gaining $1 million. Okay, there's no units on there, but the slope tells us the change that's happening over time if the x value is time. Okay, let's look at another slope. So let's say we had let's say we started it at 1, 3. And then we end up at 3, -2. Okay, and we'll do a red line for this one. Okay, we've got 1 and 3, and we've got 3, -2. And I can find this the same way. If I want to do the slope, I always start, if I want to do it just kind of the picture way, I guess, or drawing way of finding slope. We'll go over the equation way here in a second, but I always start with the leftmost point. I need to go down 1, 2, 3, 4, 5 units, right? So down 5, and then I'm going to run 2 units. So I go down 5 units and I run 2 units. So my rise then is going to be negative because I'm going down 5 units and then I'm running 2 units. Okay. So my slope for that red line is going to be -5 halves. And of course it's negative because it's going down and to the right. Okay. A lot of this should be review. Actually, the majority of this lecture I'm going to go over today should be a review from something you've done in a previous algebra class. Okay. So pretty straightforward there. Now the equation to find slope actually has to do with the change. Rise means the change in the y values. Okay, delta right there, that means change in math. Okay, if you see a triangle, it's a delta, and it means change in mathematics and change in just the way we word things in math, kind of math notation, I should say. So the change in x, or I'm sorry, the change in y over the change in x, that gives us the slope. Now the equation looks like this: y2 minus y1 over x2 minus x1. Okay, and you can use the equation, or if you can kind of visually picture it, you can use just this rise and run notation. It does the same thing. A lot of times it's just easier to use the equation because you're given 2 coordinates. Like, let's see that it lines up here. Like if we did, let's do that red line. That red line we know goes through 1, 3, and it also goes through 3, -2, right? So that red line passes through these 2 coordinates, 1, 3, and 3, -2. So if I wanted to find the slope and I didn't feel like drawing anything, I could just pop those coordinates into that equation. Now, this is x1, y1, this is x2, y2, right? So the slope winds up being -2 minus 3, right? -2 minus 3 over 3 minus 1. So we wind up with -5 halves. Hey, it's the same, right? So you can find it equationally, or you can draw it and just do the rise over the run. Now, the numbers are huge. It's hard to kind of think of rise over run. But I'll tell you, a huge chunk of calculus, which is just change, calculus just means the math of change in a way, is based on slope. It's based on how things change over time. Okay. Questions about this? I'm going to just go into more of basic examples you should have seen before. So it's like a review of some algebra topics for slope. Okay, great. So I want you now to use that equation and just find some slopes. Okay. I'm going to give you a few examples and I'm going to steal them straight from the book in chapter 2.3. So if you go to, if you've got the book out, it's on page 220 or 255. I'm going to steal some of these and we're just going to find the slope from it. Okay. So let's look at number 4. So the question says, in 1 through 10, find the slope of the line passing through each pair of points, or state that the slope is undefined. that indicate whether the line through the points rises, falls, is horizontal, or is vertical. Okay. So number 4 says -1, 3, 2, 4. So I want you to do that one. Wait, no, 5. Let's do 6. We'll do the even ones because we don't have the answers, right? 4, -1, 3, -1. And then we're going to do 10. 3, -4, 3, 5. Okay, I'm going to give you a minute. I want you to do all 3 of those. I've got to run real quick to get a bottle of water. Somebody have a question? Okay, great. So I'll give you a minute. I'll be right back. Try those 3. Okay. Let's get rocking and rolling on these. So the first one, x1, y1, x2, y2. We get 4 minus 3 over 2 minus a -1. So 4 minus 3 is just 1. 2 minus a -1, that's addition. So that just becomes 1/3. Now it's positive. So that means it's going to rise. Okay. So I don't know. I mean, if we wanted to graph this, I don't know what -1, +3 there, and then 2, +4. We'll see that it's rising as we go up and to the right, right? So it's rising as we go up and to the right. Yeah, rises, falls, or horizontal. Okay, so the second one, we've got m equals -1 minus a -1 over 3 minus 4. Well, -1 minus a -1, that's -1 plus 1. So that's 0 over -1, right? Now 0 divided by anything is just going to be 0, right? If I had nothing, I divided it, -1 ways. That's still just nothing. Okay, so we've got to go over this. If we have a slope of 0, and you can write this in the chat box if you want to for a little bit of interaction, what kind of line do we have with the slope of 0? Is it rising? Is it falling? Is it horizontal? Or is it vertical? Are you guys out there behind all those screens? Anybody want to guess? Thank you. Perfect. Well, straight with the x-axis. Yeah, that's a good way to think of it, CJ. Yeah, horizontal. This is a horizontal line. Horizontal. All horizontal lines are going to have a slope of 0. We're going to need to know that for this section, actually, and for a few sections moving forward. but all horizontal lines have a slope of 0. So the next one's going to kind of be a little different though. And if you graph this one, I don't know if anybody actually graphed it. If you do graph it, 4, -1, so 1, 2, 3, 4, -1, and 3, -1, you can kind of see, hey, yeah, this is just a horizontal line. And like Celeste said, or CJ said, it is it's parallel to the x-axis. So if you're parallel to the x-axis, you're horizontal and you have a slope of 0. So let's do this one. So we get 5 minus a -4 over 3 minus 3. So 5 minus a -4 is 9 over 0. Now this is weird. Look, anything divided by 0 doesn't work. It's one of those weird glitches in mathematics, okay? The first glitch is taking a square root of a negative. The other glitch is we can't divide by 0. It doesn't make sense, right? If I had no money and I wanted to divide it between 9 people, they'd all get no money. But if I've got no money. If I've got $9 and I want to divide it into no people, it just doesn't make any sense. So this winds up being undefined, right? Now, undefined just means we have a vertical line, okay? It's a vertical line, right? If you wanted to graph that, you'll see I've got vertical lines. And it turns out all vertical lines have a slope of undefined. And I'll tell you, we don't have to worry too much about this moving forward, because if you're looking at your book, you can see that this section's on linear functions and slope. And the issue is when we have a vertical line, and say, so 3, -4, and then 3, +5. So we got this nice vertical line right here. That is not a function, right? It does not pass the vertical line test. We go over it one time and we see it crosses an infinite amount of times. So not have to worry about it too much in this section, but understand if you wind up with a slope of 0 or a slope of undefined, we're dealing with vertical line. Slope of 0 though, horizontal. Okay. Questions before we just keep rocking and rolling? Great. Okay. So the next topic really goes into the equations of lines, which is going to lead into the linear function aspect. So the first equation of a line is y equals mx plus b. This is what CJ was trying to tell us earlier. So y equals mx plus b. What's nice about this is we can write it directly as a function if we wanted to. We're not going to at the moment. We're going to stick to just the plain equation. Now this is called the slope-intercept form of a line. Okay, the slope-intercept form. It's called slope-intercept because your slope's right there, right? And this is really where your line crosses the y-axis. So the y-intercept is actually 0b because we write it as I'm sorry, that's all goofy looking, but it's a y-intercept and it crosses at 0b. Okay, that's where we cross the y-axis. So if we wanted to look at like graphing one of these, if we had y equals, let's say 3x minus 1, and we wanted to graph it, this should be a nice just basic review on these. Okay. If I wanted to graph this, it tells me exactly what to do out of it. So this is the slope, and this is where I need to think, even though it's a whole number or an integer, I need to think of it as a fraction because it gives me the rise over the run. This, though, tells me where I cross the y-axis, right? So b equals -1. So if I wanted to graph this, let's pull out a different color. If I wanted to graph this, now I'm going to tell you, this is written out of order. You really should have the intercept first because that's what you would graph first. This tells us the change in the line, but it doesn't tell us where to start, right? The slope just tells us how quickly it's rising or falling, or maybe it's flat. But this tells us where to start. So really, your line should start, or the equation should start with a b, but it doesn't. They didn't consult me. So we're going to put b first, -1, and then we're going to graph the change. So it goes up 3, rises 3, and then over 1. And boom. We have the graph of this line. That's what's nice about this equation, right? from the equation, we can graph the line. We don't know any coordinates on this equation, right? I mean, I know we know -1's an intercept, but we might not know any coordinates. We can graph the line right out of the equation. The other thing that's nice is, of course, we can write it as a function, like we talked about earlier in chapter 2. This can be written as, f of x equals 3x minus 1, because the y is already by itself. So it can be written as a function in this notation as well, which is nice. Okay. Any questions? Let's go over a few of these that kind of look different, but they're not. And actually, I'm going to use a new piece of paper because I'm going to give a few different examples that you might see that we need to just know how to graph. So let's say we had, let me give a few, let's see here. So we'll do a bigger graph over here because I'm going to put a lot of lines on it. Let's say we had y equals -x plus 2. And then let's say we had y equals 3x. And then let's say we had y equals -3. Okay, these are all just a little different, but they pop up and we need to know how to graph them. So first off, let's do this top one. 1, 2, 3, 4. I don't need that much space. X, we've got y. Now, look, if this first one, the y equals -x plus 2, I've got to realize that whatever's in front of this x is my slope, right? So it's -1. I'm going to think of it as -1 over 1. This, though, is where the constant, right, is where we cross the y-axis. So I'll use that green color so I'll get it out. So I'm going to cross it +2. But I'm going to go down 1 and then over 1, right? Down 1 over 1. I could keep going like this forever. I can go the other way as well. Down 1 over 1, kind of a vice versa statement, would be to the left 1 up 1, right? And then I would have this nice straight line with a -1 slope, right? It's falling to the right because it is negative. So let's look at the second equation. Now, the second equation doesn't have a constant. You're more than welcome to write 0 here if that helps you, okay? But it does not have a constant. It has a slope. M equals, we're going to think of it as 3 over 1. But it doesn't have a constant. So what that means actually is our y-intercept is 0, okay? We're going to cross the x-axis at 0. Or I'm sorry, the y-axis and the x-axis, but the y-axis at 0. So we're going to cross right here, and we're going to go slope 3 over 1. So up 3, then over 1. Now, vice versa, I can go down 3 and to the left 1. Okay? I'm going to try to make this nice straight line right there. Boom. Okay? There we go. And then lastly, we've got y equals -3. Well, y equals -3 doesn't have a slope, right? Now, it does have a slope. It's just we can write it as 0x minus 3. So the slope turns out to be 0. Where we cross the y-axis is -3. So if we go back a few slides here, we said, hey, if we had a slope of 0, we had a horizontal line. That's exactly what's going on. Remember, slope is the change. As x is increasing, it's how far we're going up or down, right? So if we're over here, as x increases by 1, we go up 3, right? But for this example, we're not increasing or decreasing. It's 0. So what happens, let's use red. So we're going to go through -3 on our y-intercept, but as we increase, we don't go up or down. So we're just flat, okay? We're parallel to that x-axis, okay? Now, for this section, we're not going to have an x equals a number. I'm going to go over an example. I'll put it in pink here, okay? I'll go over x equals like 2. But listen, we're not going to have that because this is a vertical line. We don't include the slope of vertical lines because they're undefined. So x equals 2 would be stuck at the x-axis right here at 2, okay? But you're not going to see that in this, so you're not going to see it. You might see it, but it's not going to be in the function aspect of this section. It's a vertical line. It's just stuck at x equals 2. And really, that's what's happening at y equals -3. We're stuck on this axis at y equals -3. This is the y-axis, right? And we're stuck at -3. Here's the x-axis, and we're stuck at x equals 2. Okay, guys, are there any questions about these 4 graphs before we get into the more equational side of this? Okay, we've got to find equations of these lines. Any questions? Okay, sweet. So let's find equations now. So the way you find an equation is actually, I'm going to enter, or the way I do it, and the book does it, so that's why I'm doing it this way, is we've got to introduce a new formula. And the other formula we're going to introduce is the point slope form of a line. The point slope form looks like this. Y minus y1 equals m times x minus x1. And we're purely only going to use this to get us into y equals mx plus b, okay? The reason we're going to use this is because throughout this chapter, we're going to be given a point and a slope. And we've got to figure out the equation of a line. We got to figure out y equals mx plus b. We've got to put it into this formula first. As we know, m is the slope, and the point is going to be that x1, y1, okay? That's the point. And I'm going to steal a real basic one from the homework just to show you what I'm talking about. This is number 12 in the homework. Actually, I'm going to do number 14 because it's got a negative sign. Number 14 states we've got a slope of 8, and we go through 4, -1. Okay, and the question states, in exercise 11 through 38, use the given condition to write an equation for each line in point slope form and slope intercept form. So I'm going to stick on point slope form first. And what's happening, if we wanted to graph this is a really steep slope, right? 4, -1, okay. So if we wanted to graph this, we're going through 1, 2, 3, 4, -1. And then we know we've got this slope of +8. So we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8, and over 1. So we've got this really steep slope like that, okay? So this is the line that this is describing. You don't have to graph this. I'm just trying to give you the visual of it. But this is the line that's described here. But instead of graphing it, we want to put it in point slope form. So all we're going to do is take this information and put it into this equation. Now look, this is our x1, y1. This is our slope. So if I want to put it into this equation, it's going to be y minus my y1, so that's a -1, equals my slope, right, times x minus x1, x minus 4. Now I'm going to clean it up because 2 negatives make a positive. So I get y plus 1 equals 8 times x minus 4. So this is point slope form, okay? That is point slope form. Are there any questions about point slope form? We're going to use it in like the next 5 examples, but I'm going to purely use it to get us into y equals mx plus b. Okay, so the way I get us into y equals mx plus b is I've just got to get that y by itself, right? We know the equation for y equals mx plus b is y equals mx plus b, right? So the y is by itself. So at this point, all you've got to do is get that y by itself. So I'm going to switch colors here just to show you it's the next part of this question. The next part says for each line, put in point slope form and then slope intercept. So now I'm going to distribute the 8, and I get y plus 1 equals 8x minus 24. Wait, 8 times 4 is not 24. 8 times 4 is 32. right? And then I'm going to subtract 1. So y equals 8x minus 33. Slope-intercept form, right? Boom, slope-intercept form. So it's really easy to go from point-slope form to slope-intercept form. You just have to solve for the y, okay? That's all you have to do. If we're given a point and a slope, I'm going to put it in the point-slope form, and then I just solve for y. Those are the 2 steps, okay? Those are the 2 steps. Questions? I'm going to just do a few more examples, okay, that are kind of weirder. Okay, so let's say we had let's say we had, I'm going to steal this one. This is number 16. We've got a slope of -5, and we go through -4, -2. Okay, so same thing. It says put in point slope form, and then then find slope intercept form. And I'll tell you, I know to do point slope form because I'm given a point and I'm given a slope. Okay, so it's pretty straightforward. So I'm going to put in point slope form first. So I've got y minus a -2, right? That's my y1 equals my slope times x minus my x1. Now I'm just going to clean this up because 2 negatives make a positive. So y plus 2 equals -5 times x plus 4. So there is my point slope form, right? So there's my point slope form. And now for the second part, to get into slope intercept, all I have to do is solve for this y value here. So I'm going to distribute the -5, because in y equals mx plus b, we do not have parentheses. So I get y plus 2 equals -5x minus 20. Then I'm going to subtract the 2, and I wind up with y equals -5x minus 22. Okay, and boom, now we've got it in slope-intercept form. Okay. Questions? It's not too crazy. We can throw weird curveballs with it, which I'm going to here in a minute, but it's not crazy. Okay. I'm going to give you an example, and I want you to try it now. So let's say I had, this is number 24. So we've got a slope of -3/5, and it goes through 10 -4. Okay, it goes through 10 -4. I want you to try this one. I know it's a fraction. You can use a calculator, but try this one. I'm gonna give you a few minutes. So first, the question states put in point slope form, put in point slope form, and then put in slope intercept. So what we've been doing the last 2 examples. Okay, put in point slope form and then put in slope intercept form. Try that. Okay, let's do this one. So we've got, now we got a fraction, so I know it's gonna be a little goofier, but we get y minus, I chose the blue, y minus a negative 4 equals our slope times x minus 10, right? So I'm gonna clean it up just a little bit for point slope. So two negatives make the positive. And then there we have the point slope form, right? So now let's switch this to, what kind of color do we want to do? Let's do green. I've got to distribute the negative 3/5 through. So I get y plus 4 equals negative 3/5 x. Do negatives make a positive. 10 times 3/5 would just be 6. Because that's 30 divided by 5. And then I subtract the 4. And I would get y equals negative 3/5 x plus 2. Okay. So that's my y-intercept form. This is my point slope form. Okay. Any questions, comments, or concerns? Okay. Well, I'm going to do another example. Let's say we were given 2 coordinates, and you know what? Let's make this more interesting because I feel like I've done a ton of examples. Let's make it something that is kind of linear over time. Let's say, let's see if we can find something that might be linear as time increases or decreases. Okay, I'll tell you. Let's say we were working on a weight loss plan, right? We're trying to lose weight. We're looking at pounds. We're looking at, and we weigh ourselves let's say we weigh ourselves each week, okay? And we know if you've ever done a weight loss plan, the first week you lose a ton of weight, and then like after that, it kind of settles down and smooths down. And let's say after, now I'm going to make somebody up here. Let's say after the 3rd week, you were at 195 pounds, right? And then you go about your time. So, and then you keep working your butt off, I guess is a nice way to put it. And after the 6th week, you're at 182 pounds. Okay. Man, you dropped 13 pounds over 3 weeks. That's crazy. I should have made this a lot smaller. Let's make it 188. That's kind of more believable. Okay. So before we get started, I've got to define what X and Y are. I'm going to say X is going to be weeks. Okay. And my Y value is going to be my weight, right? I am not at 188. I wish I was. That's a lot. Actually, I'd probably be too skinny. But X is weeks and Y equals weight. And I noticed that this is creating kind of a linear trend. Like however I'm working out, it's pretty consistent with the linear trend. I mean, maybe it does something, it's going to do something, some weeks you lose more, some weeks you lose less. But what I'm noticing is it has a down trend line to it, right? Because whatever I'm doing is working. So I want to kind of know what that trend line is. Well, I know these 2 points line up on that trend line, okay? Wherever they are, they line up on that trend line. And I think I can kind of make a little prediction on how much I'll weigh in, 12 weeks or so. So first off, if I wanted to find, so the goal here is going to be find the equation of the line for weight, right? So really what that's asking is find y equals mx plus b. It wants us to find y equals mx plus b. So if I want to find y equals mx plus b, the first thing I need to do is find the slope. I've got 2 coordinates here. I can find the slope of this line, okay? So let's find the slope of this line first. So m equals, this is x1, y1, this is x2, y2. And we've got 188 minus 195 over 6 minus 3. So 188 minus 195 would be what, -7? And then 6 minus 3 is a +3. Okay, now we would typically write this as a decimal because it's a real world kind of thing. So in the real world, we want to know, hey, what's actually happening? But I'm going to stop here and I'm going to talk about interpreting this as well. Now, if I wrote this as a decimal, -7 divided by 3 is -2.33. Holy cow, yeah, this is like probably too much weight each week. You're losing. But what this means, I'm going to interpret both of them because we have to think of them as in terms of slope or as weight and weeks. Remember the numerator, which is the change in y, so that's weight, that's pounds, right? The denominator is weeks. So if I wanted to interpret this slope, what it's saying is if we stay on this trend, we should expect to lose 7 pounds every 3 weeks. Okay, we should expect to lose 7 pounds every 3 weeks. Now, when we made this into a decimal, though, we need to think of it as over 1. So this is the same thing, just a weekly example, right? Because this is still pounds and this is still week. So we can also say, if we stay on this trend, we should expect to lose 2.33 pounds every week, right? They mean the same thing. One's just a simplified fraction of the other, okay? One is just a simplified fraction of the other. But what's important for us moving forward now is that we know the slope, -2.33. We'll use that to find y equals mx plus b. Now, I'm going to rewrite this over here because I've used my entire page. Kind of leave that up there for you. What we know now is that the slope of our trend line is -2.33. Now I rounded here, but that's fine. 2.33. And we know 2 coordinates. It does not matter which coordinate you use. I'm going to just use that first one, 3, 195. Okay? And we're going to do what we've been doing so far. We're going to put in point slope form, and then we're going to put in y equals mx plus b. Okay? Point slope form says y minus 195 equals -2.33 times x minus 3, right? This is what we've been doing the last 4 examples. That's point slope form, but we want y equals mx plus b. That's what it asked for. So we're going to distribute, and we get y minus 195 equals -2.33x plus 3 times 2.33, which I'm going to just use my handy dandy calculator. It's 6.99. Actually, that's rounds to 7. Okay. And then I'm going to add the 195. And I get y equals -2.33x plus 202. Okay. So I've found my slope-intercept form for this trend in me losing weight. This is not me. I'm not that light. Okay. But this trend in losing weight. Now, we already talked about the interpretation of -2.33. That just means we can expect to lose 2.33 pounds every 1 week. 202 is a little different. Let me run right through it. The 202 interpretation is a little different, though, right? Think about this. If I put if x equals 0, so week 0. The week 0, right? If I put x equals 0 in here, I'd get y equals 202 pounds. So the intercept actually is where I started with weight-wise, okay? That's where this trend line anyway starts. It might not be where I actually start, but it's where the trend line starts. The trend line is saying I start at week 0 at 202 pounds, okay? Now I'm going to write this as a function because I can. So I'm going to write it as w of x, because we're talking about weight, equals negative 2.33x plus 202. Okay. Let me think about this. We started with two weigh-ins. If if you've done any kind of diet thing, you weigh in weekly, right? 2 weekly weigh-ins, and then we just assessed. We made a trend line out of those 2 weekly weigh-ins. Now we couldn't do this with 3 or 4 weekly weigh-ins because they're kind of all over the map, right? They're not going to be perfectly linear. But now that I have my trend line, if I stay on this same weight loss, I want to see what should I expect is my predicted weight for week, let's say week 10. Okay, what's my predicted weight for week 10? Well, week 10 is an X value, right? So what we're really asking is W of 10. We want to know what's W of 10. So negative 2.33 times 10 plus 202. We just plug it in, and it's going to tell us the prediction. So W of 10 would be negative 23.3 plus 202. Man, I'm getting all the things out of order. So negative 23.3, hold on, let's see this, 202 minus 23.3 is 178.7. So it's saying by week 10, I'll be at 178.7. Okay. Question. Let's keep going on this. Let's say my goal weight is 160. Okay. I want to get down to 160, and I want to know how many weeks it's going to take. So this is a little different. How many weeks before I hit 160? So for this one now we're given the y value, right? I'm giving you the y value of 160, and I want to know the number of weeks. So if I go back to my equation up here, right here, I know the weight, right, the y part. So it's going to be 160 equals negative 2.33 x plus 202. Excuse me. And I'm going to solve that out, right? So I'm going to subtract 202. 160 minus 202, that's going to be negative 42, equals negative 2.33x. And I'm going to divide negative 2.33. So 42 divided by negative, oh, actually the two negatives are going to cancel. So that's 18.02 equals x, right? So we're saying just after week 18, I should be at 160 pounds if I stay on this same trend. Of course, in reality, that trend might not stay true, but if I stayed on this same trend, I should expect to be at 160 right after 18. Now, look, if you're very discreetly talking in weeks, our answer would actually be 19, right? Because I'm not going to hit 160. I'll be a little less than 160 until my week 19 weigh-in. Okay, that's like a little real world aspect of this example. Okay, man, it's a long one, guys. We went from these two coordinates, defining the slope and interpreting, right? Which you can go back in the video and watch if you're still kind of struggling with that. Then we made the equation of the line, right here. So the equation of the trend line. And then we made some predictions. How long is it going to take? Or what's the weight going to be in week 10, right? And then how many weeks before we actually get down to a goal weight? Okay. Pretty neat stuff. Questions? Comments? That's okay, Talon. You just have to go, you need to go back and watch the first part of this video. Questions. Okay. So let me make sure I've kind of hit everything. I'm not going to talk about the last few, but I want you to go over them. And I know that sounds goofy. It's because they're in the book and I like them, but I want to see, I'll probably start off tomorrow, or not tomorrow, but start off Thursday with an example from the very end. But I want you to look at it first. I don't want it to be the first time that you actually see the content. Okay. So I'm going to give you some examples to do in the back, the application exercises that I'm not going to go over in this regular lecture, but I'll go over at the beginning of the next lecture. Okay. So let's see. For homework, this is 2.4. I'm sorry, 2.3. For homework, this is on page 255. And I want you to do 1 through 71 odd. And then we're going to skip over to the applications, 87 through 92. Now, for these, I want you to do all of them, okay? I know you've only got the odds in the back, but we'll talk about the evens too at the beginning of the next lecture. Okay. Any quick talent, I would just go back and watch this. Well, I'll have it up on in that playlist shortly. Let's go. Do you guys have any questions about today's lecture or anything in general? Okay, I'm going to stop the live